Okay, in this example, I'm just going to essentially find the force that's acting through each of the members and also the reaction at points A and C. So, first off, what we need to do is we need to realize that everything's static here. So, each point is essentially at equilibrium. So what we can do is we can look at each and every joint and do a quick free body and equal out the forces that way. And then we can backtrack and find what the reaction forces are in each member and at A and C. So let's start off with the point B where the forces, the 100 pounds, is reacting. So I'm going to do a quick quick drawing of it. I'm going to just call it joint B. And what that will look like is you have a big point with 100 pounds going directly down on it. And at a 45-degree angle, you'll have F1. At 60 degrees, you're going to have F2. There we are. So what we need to realize here is that we just need to balance this out like we did in the beginning of this entire series. It is sigma fx equals 0. Well, let's just break that down. Well, the x component, if we were to use this x and y, then that would be, well, the 100 pounds is only in the y component, so we don't even worry about that. We just need force 1 and force 2, right? So that would be force 1 times sine of 45, and that's in the negative direction. Okay, plus, and this is going to be force with the member 2, sine of 60. Okay, so what does that equal then? Well, if we know that that equals 0, then we can kind of solve for one another in terms of each other. So let's just solve for F1, or F2, sorry. And what that will equal is we'll bring it all to the other side. You have F1 sine 45 all divided by sine 60, which, if you work out that math, that will equal 0.8165 F1, which is great. Then if we do forces in the y direction, we can write an equation for that. We have negative 100, and actually, since I have a direction here, the way I have it drawn, everything's kind of negative, right? So we know that we're going to get some kind of negative value because we're basing it off of the drawing I do here. So we just have to keep running with that. That way we don't get in trouble. So what you have is you'll have F1, that'll be minus F1 cosine 45, plus, and actually no, that's not plus, that would be minus F2 cosine 60, and that should equal 0. So if you solve for that, what you're going to get, and I can just, I can just work it out for us. F1, it'll be negative F1 cosine 45 minus F2 cosine 60 is going to equal 100, right? And then you got to plug in your F2, which you have from this line. It's what you already solved from the sigma fx. So then, as we go through that, you'll get essentially what would equal out to be negative, let's see, F1 cosine 45 plus 8165 F1, because we're just plugging this in. This is where your F2 was, times cosine of 60 equals 100. Well, good. Then you can kind of revert back and keep going, and eventually you're going to get negative 1.115 F1. And this should be a negative, sorry. Okay, so 1.115 F1 equals 100. Which then, you'll find that F1 equals negative 89.67 pounds. So that's our F1. And the reason it's negative is because it's actually in tension. I mean, it's actually in compression. So that's what you just need to realize, is that you are getting in compression, and that the answer is an appropriate answer. So let's work it out. Let's keep going. Going to get your F2, which is going to be, let's see, F2 is going to, we'll just use the equation from above, right? That equals 0.8165 of F1, which that'll equal 73.22 pounds, negative. Okay? Equals F2. So now we have two answers so far. Let's keep going. Let's go to joint A. Go to joint A, you realize that once you get that initial joint, then everything just kind of falls into place. We look at another joint. We have, essentially, you have weight that will be pushing down on the 89.67, right? Then you're going to have your RA, which is going to be reaction at A, and then also you're going to have your force, which I'm just going to assume is in that direction and going to the right, and that'll be your force 3. And what you'll realize is that RA is going to equal, the sum of the forces is going to equal RA minus 89.65 or 67 times the sine of 45 degrees. So essentially RA is minus 89.67 sine of 45 equals 0. That means RA is going to equal 89.67 sine of 45, which coincidentally RA will equal 63.41. Very cool. That'll be pounds. So now we have our reaction. Let's do the other way. Just do a sum of, this was sum in the y direction. Do the sum in the x direction. And what you'll get is almost exactly the same thing, right? You're going to get, not RA, but you're going to have F3 minus 89.67 cosine 45, which we already know the answer to this. That equals 0, right? So we know that F3 is equal to 63.41 pounds as well. Okay, so now we have F3, we have F1, we have F2, and we have RA. Let's find RC real quickly. And I'm just going to do joint C really small down here. Sorry about that. And it is going to equal, doing a little joint draw, 73.22, and it's 30 degrees. This is 30 degrees here, and you'll have RC. What does that equal? Well, you're going to just get 73.22 sine of 30. That's minus that whole value, plus r of c equals 0. Thus, r of c must equal this. R of c equals 73.22 sine of 30 degrees, which equals 36.61 pounds. And that is RC. I'll see you guys in another video. Have a good one.